Today we're going to go through the procedure for the separations lab. To start with, we're going to take a clean 150 milliliter beaker and we're going to mass it on our analytical balance. To start with, we're going to make sure it's zeroed out. Okay, and then we're going to mass our beaker. Our balance says that our beaker weighs, or is massed at rather, 63.7526 grams. And remember, you have to write all of the digits that they give you. Once you have the mass of the beaker, you can take it out and you put your sample in it. You'll get an unknown sample from your professors. I got sample number 1. So we'll write our unknown sample at the top of our sheet, and we'll put the sample in our beaker. Be sure to get all of the sample out, because sometimes little grains of salt or sand might get stuck in there. So make sure all of it gets out of your file before moving on to the next step. Once all of your sample is in your beaker, you're going to mass it again. Our sample of our beaker with our sample is now 67.0485 grams. Now, once you have the sample of your beaker and of your beaker with your sample, you can find the mass of your sample just by subtraction. So 67.0485 minus 63.7526. So from that, we get that the mass of our sample is 3.2959 grams. Once we have the mass of our sample, we'll move on to the next step. Once we've finished massing our sample, we come over to the fume hood to do our first step, which is going to be the removal of ammonium chloride from the rest of our unknown. This is done via heating it to make sure that to allow the ammonium chloride to sublimate out of the mixture. To do this, we'll take the beaker with our unknown and we'll put it on a ring stand, and we're going to take our funnel trap, which is going to be used to catch the ammonium chloride as it sublimates away. If we don't catch it, it'll end up floating into the atmosphere, and we don't want that because it's not really the most healthy substance in the world. So we take our funnel trap and we put it nicely on top of our beaker, and then just to make sure it doesn't fall down and break because it's made of glass, we're going to put a nice second ring around it to hold it in place. Now, once our sample is in place, I'm going to turn on the gas. If I can remember what way to turn it. And I'm going to strike my Bunsen burner. Now, as you can see, it's a little powerful, so I'm going to turn it down a bit. Once we have a nice flame that's still hot, but not too hot as to cause damage to the glassware, you're going to take it and you're going to steadily heat your beaker filled with your sample. Now, I'll admit, this takes a while. As it says in your instructions, this should be about 10 minutes, give or take. Some of you might be a little longer, some of you might be a little shorter. So as hopefully you can see in the video, you can see white vapor starting to come off of the unknown as I'm heating the beaker. This is the ammonium chloride sublimating off it, turning into a gas straight out of the solid phase. Now, initially, a bunch of it's just floating under the funnel trap, which is unfortunate, but eventually it will start to stick, and by the end of it, the funnel trap should be completely coated in a white ammonium chloride as more of it starts to sublimate off and it starts to get really in there. So as you can see, a lot of our ammonium chloride has come off of the sample and it's coated onto the funnel trap, as you can see by this white substance that's coating it, but it also coated onto the sides of the beaker itself. Now, sadly, while the funnel trap does work to catch a lot of it, it's not going to really allow us to get rid of all of it. So once most of the ammonium chloride is out, we're going to have to remove it. So take it off. put the funnel trap over here to rest. And I'm going to turn my Bunsen burner back on. And I'm going to heat the last bit of this off. And for this step, you want to be careful with it, but you can hold the Bunsen burner on its side to try and make sure you get some of that ammonium chloride off the sides of the beaker as well. If you heat your beaker too quickly, too fast, it can sometimes cause it to shatter, so you do want to still be careful. But these things are designed to be heated, so they can take the heat if you're smart about it. So as you can see, all of our ammonium chloride has now been removed from the sides of the beaker. Once it was all gone, I still heated it for an extra 30 seconds to a minute just to make sure it was all gone, but for the purposes of your lab, that's not overly important. However, the thing to be really careful about is you've just spent the past 10 or so minutes heating this with a really hot flame. Don't touch it with your bare hands. Instead, you're going to take your beaker tongs, which are these nifty tongs with a coating of plastic. You're going to carefully remove it and put it down here for it to cool on the ceramic circle on the other mesh. Once it's cool enough, we'll go back and we'll weigh it to see how much ammonium chloride we lost. Once your beaker and sample are cool enough to hold comfortably, you can come over and you can mass it again. So, double check that it's nice and zeroed. And then we'll go ahead and put it on. Once again, reading all of the digits that they give us, which should be 4 decimal places. Mass of the beaker after the evaporation, 66.7892 grams. Now, it also asks us to put the original sample again from earlier, just so we can do some math. So that was 67.0485 grams. Now, this was our original mass of our beaker with our whole sample, and now this is the mass of our beaker with our sample minus the ammonium chloride that we just sublimated off. So, the difference between the two will be the mass of our ammonium chloride. Our ammonium chloride was about 0.2593 grams. Now, the percent of ammonium chloride can be found through some more math. Namely, the mass of our ammonium chloride, so that was 0.2593, divided by the mass of our entire sample, so that was 3.2959, and then multiplying that by 100. So, gives us the percent of ammonium chloride in our original sample was 7.87%. Next step is going to be filtering the sand and the salt away from each other. So to start with, you get a nice piece of filter paper and you're going to fold it once in half and then another time in half. So you get this nice, I guess, pizza slice or whatever. After you folded it, you're going to write your name on it in big letters in pencil, because if you do it in pen, it's going to run and it won't be there when you finish. So my name is Aaron, so I wrote that in big letters. Once you finish writing your name, you're going to really quickly come over here, re-zero your balance. Always want to re-zero your balance, and mass it. I'm just going to write the mass of my thing over here, 0.8749 grams. Now, no, it doesn't seem like a lot, but technically, by writing your name on here, you've changed the mass, because you've put those pencil marks on it, which do weigh something. So you want to write your name on the piece of filter paper before you mass it. Once you have it massed, you're going to do this with your filter paper. Stick your finger in, get a nice circle. Now, some people tend to get confused by this step. you have one piece on this side and 3 pieces on this side. So if you try doing the middle, it won't stay open. Once you have it all set up like that, you put it inside of a funnel, and you put that funnel inside a pre-masked beaker. This is not the same beaker that your sample is in, but it should be about the same size, and you will want to pre-mask this one as well. Once you have the filter paper in there, take a little bit of water and squirt it in. Now the filter paper is nice and wet, and it's going to stick and it's not going to slide. After you wet it, you want to give it a second to let the water drain. And while it's doing that, I'm going to fill this up with about 10 milliliters of water. Remember, for these steps, you want to use the water in your squirt bottles. These should never be filled up with tap water. We have special sciencey water over there for you to use. That water is free of any contaminants that might be present in tap water. Once that's done, you'll take this and you'll pour it into your filter, and you'll take your water, pour it in there just to get whatever's left of it. Swirl it around a bit, pour it right in there. I, however, didn't do that good job, so a little extra water won't hurt anybody. Now, the sand is not going to dissolve in water, but the salt will. So, as the water comes through the filter paper and through the bottom, the salt will be on the bottom with the water while the sand stays on top. However, since sand is kind of thick, it will take a couple minutes for the water to filter through. Once all the water from your first wash is through, you can take your graduated cylinder, you're going to put another 5 mils in there. We're going to want to do this a few times to make sure we got all of the salt out, because that sand is still holding onto some of that water. The sand is not going to be completely dry, so you have to do multiple washes with it to make sure as much of the salt, hopefully all of it, gets out. So that first time, you wash it through with 10 milliliters. I did a little bit extra to get the rest out. And you're going to do it 2 more times, except with only 5 milliliters. So this is the first time. 5 milliliters, pour it in there, and let it drain through. Once that drains through, you'll do it again with another 5. Once you're done filtering water through and removing all of the salt from the sand, you're going to be left with the funnel and the sand in the filter paper and the salt water in your beaker. Now, once you have this, you want to be careful because the filter paper is wet, but you're going to try your hardest to remove it from here without breaking it. And you're going to take it and you're going to put it on a watch glass. And this is going to basically just be allowed to dry. You'll take this and you're going to put it in a hood, and it'll dry over a couple of days, and eventually you'll be left with just the dry sand and the dry paper, and then a professor will mask that and they'll email you how much your sample weighed. This is why you have to be sure to write your name on the piece of paper and write it in pencil, because once again, if it's in pen, it'll run when you wet it. That way we know which sample's yours. So we're going to put this in a hood over there to let it sit for a few days. So now in our beaker, we have salt water. Now we can't just mask that because the water is going to mess everything up. So we have to boil away the water, and when the water boils away, we'll just be left with the salt. Remember, this should be a pre-masked beaker, so that way you can tell how much salt was in there via subtraction like we did earlier. So, have Bunsen burner, have my striker, and we have our setup. Because we're just boiling away water and not ammonium chloride, we can do this outside of the hood because water is good for you. Ammonium chloride, not as much. Remember, you still want to be careful with this because if you heat up the beaker way too quickly, it can shatter, but these things are meant to be heated up, so as long as you're smart, you'll be fine. And once again, this probably will take a while because you're boiling a lot of milliliters, 20 to 30 milliliters of water. So as you're heating this up, you do want to be careful because if the water starts to boil out of the beaker, you're going to lose some salt with it. So when it starts to bubble really strongly, you want to take the flame away and let it cool down for a little bit. And then once it cools down, continue heating it. Like I said, you don't want it to be just rapid boiling because that's going to mess up your data. So as the water starts to boil away, you'll start to be able to see a lot of the salt coming out and settling on the bottom. Now, if you also look around my beaker, you see some of the salt sputtered up to the top of the beaker as the water started to boil away. This is why you want to be careful. If some of that salt starts to sputter so high that it leaves the beaker altogether, your final mass is now going to be inaccurate. At the very end, you'll get to a point where you have what looks like wet salt on the bottom, and if you look carefully, because I wasn't paying attention because I was trying to talk to you guys, it's starting to sputter. So that's my fault. So I'm going to move the flame away. However, at the very end, when most of the water is gone, it'll look like a slush of salt on the bottom, which I'm hoping you guys can see on the video. This is mostly salt with a little bit of water trapped in it. You want to be really careful when you get to this part, because if you start to heat it, as that boils away, that's basically going to create bubbles under the salt, and that's going to pop, and it's going to send the salt flying. So once you get to this point, you want to be really delicate, maybe just 1 second at a time as you heat it to try and get that water to boil away, but not so fast that it creates a big bubble and chunks of your salt start to fly out of your beaker. So as you get to that last step, when you're heating it carefully, try and make sure chunks of salt don't blow away, it's going to start to crackle. It'll sound like Rice Krispie treats when you pour milk into there. Once that crackling has mostly, if not entirely, gone away, that's when you know your water is gone. If there's a little bit of water left, it'll be fine, because that beaker is going to be so hot that it'll start to drive it away on its own. So it doesn't have to be completely gone, just like you're not really hearing it that much anymore. However, remember, we've once again spent the last 10 minutes or so heating this with a Bunsen burner, so it's going to be very, very hot. So take your trusty beaker tongs, you're going to take it off there, and you're going to put it onto the ceramic circle on the other mesh you have sitting down there. You don't want to put this directly on the bench, because the bench is cold and the glass is hot, and that can cause it to shatter. Once this gets cool, you can mass it, and then you can do the same math from before to figure out how much salt you had and what percentage it was. However, because I showed you that math earlier, I'm not going to show it to you on this video now, because this video is already long enough, and I think you guys are smart enough to do it on your own.